light bulb, etc. But in a broader sense, if we look, then we can say light is a form of energy, form of energy, which enables us to see things, which enables us to see things. It means if there is no light, we will not be able to see anything. Just close your eyes. Are you able to see anything? No. So it proves that light is very important for observing the things around us. Clear? All right. So when we discuss about light, there are certain other aspects about light. Light is having a dual nature. We will discuss in our grade 12 class that light behaves both as a particle and as a wave. Here, we are not concentrating on the dual nature of light. We are going to discuss some basic characteristics of light. Among them, the very first characteristic is that light shows particular behavior as light travels in a straight line. In a straight line. What does it mean? This is the very first basic characteristic of light that we know. What does it mean? It means that whenever the light is coming from a light source, let's suppose from the sun rays that we are receiving, they are traveling in a straight line. But there is a catch over here. We think that it always travels in a straight line. No, it is not the case. It means when light travels in a medium, in a single medium, let's suppose light is traveling in air. So until and unless there is change in the density of air, light will travel in a straight line path only. But after a while, let's suppose the density of the air has changed. It may be reduced or it may be increased. Then what will happen to the light? Light will bend from its actual path. We are going to discuss further when we will discuss the topic of refraction. Now, first of all, we'll consider this property only that light travels in a straight line. It is also known as rectilinear propagation of light. Rectilinear propagation of light. All right. So this is the very basic property that light travels in a straight line, which we also call as rectilinear propagation of light. Now, when light travels, what will happen if suppose some obstacle comes in its path? What will happen to the light then? Will it travel or it will stop there? So this gives us a question over here. Okay, let's suppose an opaque object. Take an example, a stone, a wall comes in the path of light. What will happen to the light then? Then comes the second property of light. What is that? Let's discuss about the second property of light. That is reflection of light. Reflection of light. Now, what is reflection of light means? This is a very good question. People generally think that it's just like only the plain mirror or a mirror in which we look our face daily that only gives us reflection. No, my dear students, this is not the correct answer for this. You know what happens? Just take an example. If consider if only the world is full of mirrors, then only will reflection will happen. Think about it. And before answering it, let's first discuss what is reflection of light means. So, what happens? We know that when light travels in a straight line, and let's suppose some obstacle is coming in its path, then what will happen to the to light? It will bounce back from the surface. What I'll give you an idea. Let's suppose this is a surface. Okay, this is a surface. Then a light ray is coming and striking the surface over here. Okay, this is from a source. Let's suppose the sun, it is coming. Now, what will happen to the light? It is coming in a straight line path, maybe at a certain angle over here, but still it is not bending. It is coming in a straight line path. Then according to reflection of light, what will happen? It will bounce back from the same point where it is striking the surface. Okay, let's consider this point as point O. Alright, so the light ray which is coming from the source of light, we call it as incident ray. Okay, then it is striking this surface. Let's suppose we are naming this surface as Mn, and the light ray which is coming from the source is AO. Then what will happen? The light ray will strike this surface Mn and it will get bounced back in the same direction from where it is coming. What does it mean? It is coming in from this direction, now it is going in this direction. Means from this side only it is coming. So let's suppose let's name this as B. So OB is the ray of light which gets bounced back from the surface. And it is called as reflected ray. Alright. And this point O, we'll draw a perpendicular from this and name it as ON. Now what is this? This is the light ray which is coming from the source. We are calling it as AO. And the light ray which is bouncing back from the surface is named as OB. And ON is acting as a perpendicular. Now, why we need a perpendicular over here? As I told you, it's not necessary that it always comes directly to the surface, the light ray which are coming from the light source. Okay, so in order to find the angle at which it is striking the surface, we are calling it as angle of incidence I, and this is angle of incidence reflection R. So in order to find the angle of incidence, we require this norm. We don't call it as a ray. Children generally commit this mistake that they call incident ray, reflected ray, and the normal ray. No, children, this is not a ray. It's a perpendicular dropped or drawn from the point of incidence. And since we are drawing it, we are constructing it, it should be with a dotted line because it is not present. Just for our ease of understanding the angle of incidence and angle of reflection, we are constructing it. That's why it should be drawn with a dotted line. All right. Now, with this, there is an association of certain laws of reflection. So, what is reflection of light? First of all, we'll define this. Okay, what is reflection of light means? All right. So, I'll write the definition. Bouncing back of light rays after striking a surface is called reflection of light. Now one question comes over here. Mom, is it necessary that only from a plain mirror or a shiny object the reflection will come? No, it's not necessary. If only that happens, then we will not be able to see any other object. Just like we are able to see the walls, the floor, the ceiling, the door, the clothes, a human body, everything in the nature we are able to see. So it proves that all of these surfaces are not shiny in appearance. All of these surfaces are not having a plane mirror attached to it. Still, we are able to see them. So this proves that reflection can occur from any type of surface. Just plain mirror or a reflecting surface like a shiny object, like a new utensil made of stainless steel that we are purchasing, they are giving more clearer reflection as compared to the other reflecting objects like a wall or a floor. Okay, on the basis of this criteria, first of all, we will discuss the two types of reflection that occurs in nature. Okay. So what is reflection of light, children? Bouncing back of light rays after striking a surface is called reflection of light. Means light rays coming from a source and then it is striking, then it is colliding with the surface. Then what happens? After striking the surface, it will back to the original direction. It will travel back to the original direction from where it is coming. Okay. On the basis of this definition, we are having two types of reflection. Okay. Let's see what are they. So, types of reflection. First one is regular reflection. Now, what is regular reflection? Consider this ray diagram. We are having a smooth, shiny surface like a plane mirror, right? And this light ray is coming and incident over here. Okay, draw a normal at this point, and it is reflecting in this direction. Okay, arrow marks are very important, children. If you don't draw the proper arrow marks, will not nobody can understand whether the light is incident or whether this particular ray of light is reflected. All right. So at this point, we are having this ray A O as incident and OB as reflected. Consider in another way, which is parallel. At this point, we are drawing another, and it is going like this way. Okay, let this be this as S. Let's suppose we are considering R, right? Mn is the surface. So what we are observing over here, that the two rays of light which are coming from the source, let's again consider the sun as the source. Two different rays of light are coming to the reflecting surface Mn, and both are parallel to each other. And after reflection, what we are observing, the first ray that is incident is AO, and then is reflected as light ray OB. The second is ES, and it is reflected as SR. In both the incident light rays, this and this, these are incident rays. Both are parallel to each other, and this two are reflected light rays. They are also parallel to each other. So, in this case, we can say it is a regular reflection. In regular reflection, what happens? Incident light rays are parallel to each other, and after reflection from the reflecting surface, the reflected rays are also parallel to each other. Such type of reflection we call it as regular reflection. Okay. Now, this is an ideal condition, hypothetical condition. Practically, it is not possible because no surface in this world is 100% smooth or 100% shiny. Okay, but to consider, we consider plane mirror as a 100% reflecting surface. So the reflection from a plane mirror is considered as regular reflection. All right. Next is irregular reflection or diffuse reflection. What does it mean? Irregular or diffused reflection. What does it mean? Now, in this case, let's take an example. This is an uneven surface. Light rays coming at this point. Let's draw a normal. Then it is reflected like this, right? Incident, and another light ray is coming. This is also parallel But when it is reflected, it goes somewhere like this. It gets intersected with the previous one. Right? Make a proper arrow. So from the sun, two reflected light rays are coming. So it is possible that incident light rays, in the first case, this is O. Let's suppose this is A, and this we are considering as B. This is we are considering S. This is B. This is Q. All right. So is it is possible that incident light rays will be parallel, even it is a irregular or a diffuse reflection. But due to the surface unevenness, you can see this surface is not a plane surface. It is not an even surface. So in that case, what happens? The reflected light rays will intersect at maybe one point or multiple points. And what happens at that point? At that point only, the image will be formed. Alright. At that point only, the image will be formed. And that is the reason that all the reflections, 99.9% we can say the reflections occurring in nature is all because of irregular or diffuse reflection, and that's why they form an image that we are able to see. Clear? Alright. So this is all about regular and irregular reflections. Now we are going to focus first of all on the two laws of reflection, and then we will discuss more about reflection from a plane mirror. Now, whether it is a regular reflection or an irregular reflection, we are having two basic laws for reflection of light. Okay, which is applicable on all types of reflecting surfaces, on any type of reflection, whether it's a regular reflection or an irregular reflection. Okay, any type of surface we are observing the reflection of light, these two laws are always applicable. What are these two laws? Let's discuss about it. So, laws of reflection of light. First law. Now understand. Before understanding, let's take a simple example. We are having a reflecting surface, an incident light rays over here. Then we will draw a normal over here and a reflector light ray, right? Put arrow marks, otherwise it is difficult. Mark everything. Let's suppose PQ over here is the reflecting surface. AO is the incident light ray, OB is the reflected light ray, and ON is the normal. Right? Now let's name them. This is incident light ray. Incident ray. You can name simply as incident ray. This is reflected ray. Okay? This we are calling as normal. Right? And this point O is point of incidence. Alright, children? Okay. Now see what the laws are there. First law. First law says the angle of incidence, that is angle I, is always equals to angle R. Now where is angle I? This is angle I. This is angle R. The angle which is formed between the incident light ray and the normal we are calling as angle of incidence. Alright? Which is denoted by the letter I. Alright? Now, and the angle which is formed between the reflected ray OB and the normal ON is called as angle of reflection. So first law says angle of incidence is always equals to angle of reflection, no matter whatever. Let's take if angle of incidence is 30 degree. Then what will be angle of reflection? It will be also 30 degrees. If the angle of incidence is 42 degrees, then angle of reflection will also be 42 degrees. So whatever may be the angle of incidence, the same will be the angle of reflection, no matter whether it is a regular reflection or it is a irregular reflection. All right. Now, this is the first law. Now coming to the second law. What the second law says? Second law says, again I am drawing the diagram over here, or we can simply write. Second law says, the incident ray, mind the words children very clearly. Now I am not talking about angle, I am talking about the ray. The incident ray, reflected ray, and the normal. All three lie in the same plane. The point of incidence. What does it mean? Coming back to the diagram once again. Alright, so you just see this sheet where I'm drawing all these. This is a plane figure in the shape of a rectangle. So it is a plane, right? It is not a 3D object or it is not one-dimensional object. So the law says the incident light ray. Where is the incident light ray? This one. Okay. And this is the reflected light ray. Okay. And the normal. All three are intersecting at one common point, that is the point of incidence O. So this law says, second law says, the incident light ray OA or AO, reflected light ray OB, and the normal ON. All three lying in the same plane. They are all three lying in this plain piece of paper. They are not, none of the rays going, nor the normal is going in a three-dimensional manner or in a one-dimensional manner. Okay. And they all are intersecting at one common point, which is called point of incidence. All right. So this is the meaning of the second law, that the incident ray of light, reflected ray of light, and the normal, all three lie at a common point called point of incidence in the same plane. All right. Now, I'll tell you what common mistakes generally students do at this time. Okay. Many a times they swap the words ray and angle. Instead of, in the second law, instead of writing incident ray, they write angle of incidence. And the normal ray. So normal is not a ray. Again, I'm reminding. And in the second law, we are not talking about the angles. We are talking about the ray of light, which is incident and which is reflected. So write the correct word ray over there. Don't use the word angle of incidence or angle of reflection. Clear? And whenever it is being asked to write the laws of reflection of light, it is always better to draw this ray diagram. This is, it gives a clear image, clear impression to the checker or the teacher that yes, the child knows very well that this is incident ray, this is reflected ray, and the normal is being made properly with the dotted line and mark properly the angle of incidence, angle of reflection, the incident light ray, arrow mark for the reflected light ray, and properly show that the reflecting surface. Note, please make point for the reflecting surface also, just like we have done over here as PQ. Okay, and also denote point O as point of incidence, where light ray are intersecting with each other. Clear? So this is all about laws of reflection of light. Now, next comes about reflection. Specifically, we are going to deal with reflection of light from a plane mirror first. Right? We see our beautiful faces daily in the plane mirror and we adore how we are looking. If we are dressed up smartly, and since early in the morning, we want to see whether we are looking up to date or not, whether we are having any crease on our dress or our hair nicely combed or not. All these we look in the mirror and then we correct ourselves. Okay. Now, how this image that is formed in a plane mirror is having certain characteristics that maybe or may not be we are well aware of. So let's discuss in details about the characteristics of an image formed by a plane mirror. Before discussing the characteristics of image formed by a plane mirror, we should know how many types of images are actually formed by reflection of light. So, types of images. So, in general, there are two types of images. First is real image, and second one is virtual image. Now, I'll give some examples for both. Just give see like this. Daily, you are looking yourself in a mirror. Okay, are we able to capture that image? Not with the camera of your mobile or any camcorder or any other digital camera. Just think like that. Are we able to trace that image or locate that image on a screen? Just like when you are going to a movie theater to watch a movie, so you see there you see the image just or the movie on a screen. Is there any screen present inside a mirror where the image of yourself is forming? The clear answer is no. Right. So whenever we say about a real image, when we talk about real images, so real images are those images that we can obtain on a screen. Right. Okay. On a screen. And virtual images, they cannot be obtained on a screen. Right. So where we see this virtual images inside that reflecting surface only. Okay, just like your plane mirror. You see yourself in the plane mirror only. Although there is no screen over there, then also we are able to locate our image. We are able to visualize our image. We are able to see our image. Why so? Because the plane mirror is forming a virtual image. Okay. Now, there are some more characteristics of virtual images that we'll discuss after we discuss how the image is formed in a plane mirror. Alright. So let's discuss more about the characteristics of an image formed by a plane mirror. Okay. Characteristics. Characteristics means what, children? It means the properties, the special qualities, characteristics of image formed by a plane mirror. All right. Now, very first characteristic, very important. It always forms a virtual image. Image form is virtual. What does it mean? We cannot obtain it on a screen. We always look inside the mirror only. The image which is formed in a mirror is always behind the mirror, and behind the mirror or inside the mirror, what we say, there is no such screen over there. So the image formed is virtual. We call it as a virtual image. This is the very first property or characteristic of an image formed by a plane mirror. Now remember this, children. Whenever an image which is formed is virtual, it is also erect. Image formed is erect. What does it mean? As the object is standing upright, in the same manner, the image is also forming upright. Okay. So, do remember this thing. Whenever there is an image formed by a plane mirror, it is virtual, and virtual images are always forming erect or upright. Okay. So these are the two first characteristics. Now comes the third characteristic. Just a minute. Now, the third characteristic. The third characteristic says the image formed is of same size. Image formed is of same size. As that of the object. What does it mean? It means whatever is the height of the object, the dimensions of the object, the same dimensions are of the image. Let's suppose uh, we are seeing an image of a candle in a mirror, in a plain mirror. The candle is 12 centimeter tall. So, image of the candle which we are seeing inside the mirror is also 12 centimeter tall. Okay, so this means the image is of the same size as that of the object. Clear? Now comes the fourth property. The distance between the object and the mirror is always equal to the distance between the image and the mirror. Correct? What does it mean? Let's suppose I'm standing at a distance of 5 meters away from the mirror. So when I look inside the plane mirror, my image will also be at a distance of 5 meters away from the mirror. Alright. So it means that at whatever distance the object is kept in front of a plane mirror, at the same distance its image will be formed behind the mirror, or you can say inside the mirror. Alright. Alright. This is the fourth property. Now comes the fifth and very important property, okay, which we are expecting lots of conceptual questions on that. What is that property? Property of lateral inversion. Lateral inversion. For this, you can have a real life situation. Just stand in front of a mirror and raise your right hand. What you will observe in the mirror? Is your right hand, is the image right hand is raised up? No. The answer is a clear no. Why so? Because when we see ourselves in a mirror, the image sides are swapped up. Means the left side of the object will appear as right side of the image in the mirror, and the right side of the object will appear as left side of the image in the mirror. And that property we have called it as lateral inversion. Okay. So what is lateral inversion? In a plane mirror, the left side of an object will appear as right side of the image, and vice versa. Vice versa means the other way around. That is the right side of the object will appear as left side of the image. Okay, this property we call it as lateral inversion. This is the most important property that a plane mirror shows, and that is the reason there are certain applications of that. The most important application of this property is that the word ambulance, just see, ambulance. Okay, this word ambulance, when you see, if it is written like this, it will appear something like this. Let's suppose this is a plane mirror, and how it will appear to us. Okay, like this way. Like this way it will appear to us. So in this manner only, this word ambulance is painted on the ambulance vehicle. Why so? There is a very logical reason over here. So that in case ambulance is a vehicle which carry patients, we know it very well. Okay, so when ambulance is stuck somewhere in between the traffic, and let's suppose there is a situation like due to lot of horns honking on the road, the vehicles ahead of the ambulance are not able to hear the ambulance siren or the horn. Okay, so at least the driver of the vehicles who are driving ahead of the ambulance, when they look in their rear view mirror or the side view mirror, they will not see the image like this. They will not see the image like this. They will read it like this, and they will understand, oh, it is an ambulance. So they will clear the path so that it can reach the hospital on time and help the patient properly. All right, and this is all because of the property called lateral inversion. So you, next time whenever you see an ambulance, just look at the word ambulance, how it is painted. First of all, it is painted with red color generally. So red color is a bright color which we can see from a very longer distance. Okay. And second thing, it is painted in this manner. That is laterally inverted image. So that when the person see in his car's rear view mirror or the side view mirrors, it will appear as correct. Okay. Clear? So this is all about image formed by a plane mirror and its characteristics. Just have a quick recap what we studied till now. We discussed what is light. Light is a form of energy which enables us to see different things around us. If there is no light, we are not able to see it. Alright. Next, light, first basic property of light, that light travels in a straight line. We call it as rectilinear propagation of light. Okay. Then comes the very important property of light called reflection of light. So what does reflection of light means? Whenever light is coming from a light source and it is striking a surface, then after striking the surface, it will bounce back. It will go back in the same direction from where it is coming. And that property of light or this phenomena of light we call it as reflection of light. And it is very important to understand that reflection occurs from all types of surfaces, whether they are rough, whether they are smooth, alright, whether they are hard, whether they are soft. All types of surfaces reflect light, right? Now, on the basis of this, we are having a definition this. Bouncing back of light rays after striking a surface is called reflection of light, alright? Now, comes the next types of reflection we discussed. So, on the basis of the definition of reflection of light, we are having two types of reflection of light. One is regular reflection. Now, what is regular reflection? The reflection that generally occurs from smooth, shiny, plain surfaces. How we can define this? So, in a regular reflection, the light rays are coming parallel to the surface from the light source. You can see over here in this diagram. All right. And then after reflection also, they are parallel only. They are parallel rays of light only. Then such type of reflection we call it as regular reflection. Clear? Okay. Moving next is irregular reflection. So irregular, or it is also called as diffused reflection. Right? So in this case, what happens? The surface is not smooth. It is rough. We can name this surface as M and M. You can see this surface. It is not plain surface. It is a rough surface. From this rough surface, when reflection occurs, so the light rays, since they are coming from the light source, so they can be definitely parallel to each other. But when reflection occurs from such uneven rough surfaces, it may not be parallel. Then what will be the case? In that case, it will be either intersecting, that is meeting at one point, or they will be concurrent lines. Children, we have studied this thing in mathematics. What are concurrent lines? Lines that two or more lines that intersect more than at one point are called concurrent lines. So what happens? Where they intersect, there only the image of the object is formed. So most of the reflections that we see in our daily life around us is due to irregular or diffused reflection. All right. Then we have discussed laws of reflection of light. So what are the laws of reflection of light? There are two basic laws of reflection of light. They are, first of all, that incident angle or angle of incidence phi and angle of reflection are always equal. Now, how to find this angle of incidence and angle of reflection? Let's draw a ray diagram for that. Consider a plane surface. An incident light ray AO is coming and striking the surface. Then from the point O only it is reflecting as OB ray. At the point of incidence, we are drawing a perpendicular ON with a dotted line. Alright. Then the angle which is forming between the incident ray and the normal is called angle of incidence I. Alright. And the angle which is forming between the reflected ray OB and the normal ON is called angle of reflection R. So first law says angle of incidence is always equals to angle of reflection. Clear? Maybe whatever may be the value of angle of incidence, the same will be the value of angle of reflection. No matter whether the reflection is occurring from a plane surface or a rough surface, maybe a solid surface or a soft surface, a hard surface or a liquid surface. Alright? This law is always applicable over there. Clear? Now comes the second law. The second law says that the incident ray, reflected ray, and the normal, all three lie in the same plane at the point of incidence. Have a look again once again. So what does it mean? At this point O, the incident light ray AO, the reflected light ray OB, and the normal, all three are intersecting at one common point O, which is called as point of incident, and it is lying in this two-dimensional figure only. It is in the plane figure only. Alright. So this is the second law. It is also applicable to all types of reflection of light. Alright. Next comes types of images. So we are having two types of images. Whenever reflection occurs and the image is formed, we will have generally two types of images. First is real image. Second is virtual image. Now real. Real means actually after reflection, the light rays are striking at one point. They are intersecting at a point and the image is formed. And we can see that image on a screen. A screen can be a wall or a cellulite screen, an LCD screen, or maybe even a blank piece of paper. All these hard surfaces are called as screen. Right. So whenever we see an image after reflection of light on a screen, we call it as real image. But many a times it happens that the image will not be formed on a screen. They are forming inside or behind the mirror or the reflecting surface. Such type of images we are called as virtual images. They cannot be obtained on a screen. They will be visualized. They We can see them inside the reflecting surface. All right, where no screen is present. Okay, next comes the characteristics of image formed by a plane mirror. Why so? Because plane mirror is the one such reflecting surface which we generally consider to show regular reflection. It's an ideal condition we are considering. And we are using plane mirror very often every now and then in our daily life. That's why we should know what type of image is formed in a plane mirror. So there are five basic characteristics of image formed by a plane mirror. What is the first characteristic? Image formed is virtual. Means whatever we are seeing, whatever object is kept in front of a plane mirror, its image is formed behind the mirror only. We can see that image inside the mirror only. So it is a virtual image because we are not able to obtain this on a screen. All right. Second property or second characteristic. Second characteristic says the image formed is erect, means upright. As take an example, if the object is like this, its image will be also like this only. AB is the object and A dash B dash is the image. It is also upright only. So this is the case of erect image. And children, always remember this thing. If the image formed is virtual, definitely it will be erect only. Okay? Both the properties go simultaneously. If the object's image is erect, definitely it must be virtual. And if the image is virtual, definitely it will be erect. Got it? Okay, next, the third property. The third property says the image formed is of same size as that of the object. So whatever the object size is, maybe 10 meter, maybe 5 centimeter, maybe 2 meter, maybe 1.5 inch, the same size image will be formed behind the mirror or inside the mirror. When we see the image, it is of the same exact size as that of the object. All right. Now comes the fourth property, the distance between the object and the mirror. Let's suppose an object is kept at a particular distance. Take an example. I'm standing 5 meter away from the mirror. So my image that is forming behind the mirror is also 5 meter away. So object distance from the mirror is always equals to the image distance from the mirror. This is the fourth property. Okay. Now comes the fifth property, that is lateral inversion property. Now, for this, when you stand in front of a mirror, what happens? If you raise your one hand, let's suppose you are raising your left hand, and you just observe your image inside the mirror. In the mirror, the image is the right hand is being over there or the left hand is there. Since you raised your left hand, then when you look inside the mirror, you observe that the image right hand is being raised. Why so? Because the image that is formed is laterally inverted. The sides are swapped. Left becomes right and right becomes left. And this is the property that we see in the image formed by a plane mirror. Okay, that property we call as lateral inversion property. So in a plane mirror, the image formed is laterally inverted. Clear? And we are having an application from our daily life of this property, that is this, the word ambulance. Ambulance is a very important vehicle who carries patients to the hospital. Okay, so the word ambulance is written as its mirror image. This one is called as mirror image. Right, mirror image. And this is basically a mirror image which is laterally inverted. Just look at this letter B and letter L. There are certain letters which are laterally inverted. Alright. Why so? Because when we look inside the mirror, there are letters which appear as it is. Look at the letter A, letter M, okay, or letter U, and C. These are the same. But there are other letters which are laterally inverted. That is their sides are swapped. So The word ambulance, when it is painted on the ambulance vehicle, it is painted in the form of its laterally inverted mirror image, so that in case of emergency, when the ambulance is stuck in the middle of a traffic, or the persons are not able to hear the ambulance horn or the siren, they can at least read it correctly. Since it is written in the form of a mirror image, so in the rear view mirror of the vehicle ahead of the ambulance will read it like this, ambulance, correctly, and they will give the path to it. Alright? That is the reason why ambulance word is written as its mirror image in ambulance vehicle. Okay? So this is all about the light, reflection of light, rectilinear propagation of light, and how the image formed by a plane mirror is occurring, and what are its basic characteristics. All right. In our next class, we will discuss more about reflection from spherical surfaces. Today, we have seen how the reflection occurs from regular surface, irregular surface, and especially from a plane mirror. In the next class, when we will be coming, we'll see how reflection occurs from spherical surfaces. What type of spherical mirrors are there? What are their basic definitions? And then we will discuss one by one the image formed by a spherical mirror. Okay, what type of images they are forming, how they are producing different types of images. All these we will discuss in our next class. So, see you in the next class.